Hello everyone, welcome to the video. Today we're going to do some unit conversions. So we're going to start off with some basic metric naming rules. So on your piece of paper at home while you're watching this video, follow along and take notes and write down what I'm writing down so that you'll have a copy for yourself. So I'm going to write out these couple letters that are used for the naming process in the metric system. Alright, so some of you may already notice what these are. The first one right here is kilo. Next one is hecto. Next one is deca. Then there's the base unit. Then there's deci, centi, and milli. So each of these has a specific value that that is associated with them. So the base units are they differ for the different measurements you might take. For volume, the base unit is the liter. For weight or mass, the base unit is the gram. And then for distance, the base unit is the meter. All right, so the liter is represented by an uppercase L, the gram is represented by a lowercase g, and the m is represented by the meter is represented by a lowercase m. Okay? Be sure to write this down on your page. So when you see kilometer, that means 1,000 meters, or 1,000 grams, or 1,000 liters. Hecto means 100. Deca means 10. Then the base, that's just 1. When you have 1 meter, you have 1 meter. Deci means 1/10. So if you have a decimeter, that's 1/10 of a meter. Centi means 1/100th. And milli means 1/1000th. These are the unit labels that you will be responsible for. Kilo to milli. 1,000 to 1/1000. And then the appropriate base units. Okay, so we're going to go through a process called dimensional analysis, which is how you're going to be performing your unit conversions in this class, and it's a very important concept in chemistry and all the sciences. Say you have 1 kilometer. That is 1,000 meters, as we discussed. So you multiply, if you have however many kilometers you have, you multiply that by 1,000, and that gives you the meters. So as you go from a big to small, you multiply. So say that's left, and that's right, you multiply. Let's say you have 1,000 meters. How many kilometers is that? You take however many meters it is and you divide it by 1,000, and that tells you how many kilometers. So that means when you go from right to left, you're going to divide. So we're going to do several specific examples together, and then you're going to break apart and do a couple on your own, and then we'll come back and do a few more. So the first example, let's say you have 10 kilograms. How many grams are in 10 kilograms? Now, your instinct might be it's very simple. I can just move the decimal point. Well, as you get to more complex units and more complex conversions, just moving the decimal point will not be sufficient. So we're going to learn the method for reliably converting units without just moving the decimal point. So you have 10 kilograms. You set it up like this. You make a line that continues all the way across. And so you say, I have 10 kilograms. For every 1 kilogram, I know that there are 1,000 grams. And you be sure to always write your units as you progress along. So that means now we're going to multiply everything that's on top and divide by everything that's on the bottom. So 10 times 1,000 divided by 1, that is equal to 10,000 grams. So that is how you find how many grams are in a kilogram. Right? Next one is, so that is going from big to small, so we multiplied. So now let's go from small to big and add a couple extra steps in there. So let's say you have 2,350 centimeters. How many kilometers is that? Well, you draw your line again, and you say, okay, for every 100 centimeters, there's 1 meter. And then I say, I also know that for every 1,000 meters, there's 1 kilometer. So then you take and divide 2,350 by 100, and then you divide by 1,000, and then you multiply by 1, and multiply 1 again, and you solve it out, and you get that it is 0.2350 kilometers. I'll write that a little better, more clearly. 0.2350 kilometers. So that is how you find, that is how you do two very basic dimensional analysis problems. So now pause the video, take a break. On your measurement conversions worksheet that I've assigned in Schoology, go ahead and work out the first two on your version of this worksheet. And once you've worked those two, come back to this video and you can play the rest. But pause this video for now and go work on those two. Alright then, so let's check the work you just did yourselves. So the first question is, if you have 3.68 kilograms, how many grams is that? So following the process that we just learned, we draw our line, say, okay, well I know that for every 1 kilogram, there are 1,000 grams. So I multiply what's on the top, divide what's on the bottom, that gets rid of this kilogram unit, gives us the gram unit, and we find that there are 3,680 grams in 3.68 kilograms. All right. Next one is, if you have 568 centimeters, how many meters is that? All right, so follow our steps. For every 100 centimeters, there's 1 meter. So that'll cancel the centimeter units, give us the meter units. So we multiply what's on top, divide what's on the bottom, and we find the answer is 5.68 meters. So those are the answers to the two problems you just did yourselves.
We will finish this for homework.
All right, so now let's move to there's a question in the PowerPoint. It asks how many minutes are in 2.5 hours. So we say we have 2.5 hours. What do we know? We're trying to get smaller, so we're going to be dividing. So we know that for every 1 hour, there is 60 minutes. So we can say there's 1 hour here, and here's the 60 minutes. Oh, so we're actually multiplying. Excuse me. So because we're getting smaller, we're going to multiply. So that takes care of our hour units. That gives us a minute. This is a correct statement. For every 1 hour, there's 60 minutes. So then we just multiply out and divide, and we see that the answer is equal to 150 minutes. So there are 150 minutes in 2.5 hours. All right, let's do one more together, and then I will leave you with one to do in your notes on your own, and then we'll check it together as a class live. So how many hours are in 2 years? So we have 2 years. How many hours is in that time? So we start off with what we know. We know that for every 1 year, there's 365 days, assuming it's not a leap year. So we write that, but we're not quite where we want to be, so we're going to do another level. We know that for every 1 day, there are 24 hours as well, 24 hours in a day. So now we go back and look, and we see that our units cancel out here, and it leaves us with hours. So, and these are two true statements. There are 365 days in a year and 24 hours in a day. So now we just multiply out the top and divide away the bottom, and that gives us that there are 17,520 hours in 2 years. So that is how you do a slightly more involved conversion. All right, so now the one I'm going to leave with you to do as a class is how many seconds are in 3 years. So we have 3 years is equal to how many seconds. So I'll give you some time to do that on your own, and then as a class we'll come back and check on it. So thank you for watching. I'll see you next time.